Hi math students, it's Miss Carol and we are on Unit 3, Lesson 15. This is the last lesson of Unit 3, so this is where you're going to submit the project once we're finished with this. So we've got 5 questions. This is a little bit of a different project. It's going to send us out into the internet to do a few things. But you might notice that I'm not going to follow the directions exactly here. This is the benefit of you listening to the recording. You'll see how I do it, and you can do it exactly like I do it. You can copy me verbatim if you'd like. This isn't okay to copy verbatim on discussion boards, but on these projects it certainly is, because then I'll know you listened to the recording. Okay, so first question, it says, go to the web and search for examples of quadratic functions in the real world. So the example that we are going to use is this one right here. We are going to use the gateway arch, and I'm sure that some engineers out there would tell us that this isn't a perfect parabola and it actually is represented by a little bit different shape. That's totally fine. For the purposes of what we're doing, this is a parabola. So what we're going to type in the first box there is that we are looking at the gateway arch in St. Louis, Missouri. Okay, spelled it all right. And second question, describe how to recreate this image on a piece of grid paper. So in my research, I found out that the St. Louis arch is 630 feet from post to post and 630 feet tall. So that kind of makes an interesting study for us. And if I were to do that on a grid, there's a couple ways to do it, but I think the one that kind of resonates the easiest with me is that one side of the arch, 1 foot, would be at 0 and 0, okay? The other one would be at 630 and 0, if these are my x and y coordinates, okay? And then remember that I said that at its highest point, it's 630 feet tall, so this is 630, okay? And that's halfway in between the two. So I know that half of this distance from 0 to 630 is at 315, right? So this point is actually at 315 and 630, okay? So I also know that these are my h and k values, which are my vertex. Okay, these are my roots. My roots are going to be 0 and 630, and my k or h and k values, or my vertex, are going to be 315 and 630. So that's what makes the most sense to me. You could move the vertex over to the y-axis, and then you'd have a negative 315 here, and your vertex would be at 0 and 630. We're going to kind of get a similar quadratic equation either way, but that's what I have decided to do there. So the answer that I would give here is that I would say roots are at 0, 0, and 630, 0. Vertex is at 315 and 630. Axis of symmetry is always the the x value of your vertex. So x equals 315, and that would be this line that I drew up the middle here. So that would be right there. That line is our axis of symmetry. And let me just go ahead. I guess I never fully drew this parabola, so it would look something like that. Okay? Okay, so let's scroll down to question 3. And it asks, identify the vertex and the y-intercept of the parabola. So we already kind of did this, but it's not going to hurt to write it in here again. So vertex is at the h and k. Vertex equals 315 and 630. And the y-intercept, where it crosses the y-axis, is right there at the origin. Of 0 and 0. All right, so if your parabola isn't already predetermined, your moving around can kind of help you with gathering the actual equation for how y changes in regards to x. Okay. Next question, explain how to write an equation for the parabola with the information from our previous answer. So one thing I'd like to do here is use the vertex form. And the vertex form is using the using the vertex form of a quadratic equation, we know that, so y equals a times x minus h squared plus k. So that's our vertex form, okay? Where the vertex is at h and k, and then what we have to do is solve for a. So I'm just gonna type this out. Y equals a times x minus 315, remember that was my h value, squared, plus 630. Well, I can use any x and y values that are on this parabola. So I could use 630 and 0. I could also use 0 and 0. So 0 and 0 seems like the easiest way to go to me. So I'm going to go ahead and say plug in 0, 0, 0 for x and y. So 0 now equals a times 0 minus 315 squared plus 630. Okay. Now 0 minus 315 is a negative 315, and negative 315 squared is 99,225. I'm going to just go ahead and move that 630 to the other side right now. I'm going to say negative 630 equals a times 99,225. Okay. Oops. All right, so now I need to just divide both sides, that negative 630, by that 99,225, and when I do that, I get negative, so this is going to be my a value, a equals negative 0.00635. Okay? So now I have all the values. I have a, h, and k that I can plug in. So y equals that negative 0.00635 times x minus 315 squared plus 630. And that is the equation for this parabola. Okay, negative makes sense because it is a downward facing parabola, so that a value should indeed be negative. Our vertex again is at 315 and 630. So this is all making good sense here. Okay, We didn't so much explain it as we demonstrated it, but hopefully that makes sense. So the roots, the axis of symmetry, and all of that, let's go ahead and just write it again. We did that earlier. In fact, I am just going to do this because no need to type more than we need to. Roots were at 0 and 0, 630 and 0. The vertex was at 315 and 630. And the axis of symmetry was x equal 315. And so that represents where the feet of the arch touch the ground and the highest spot at the arch. The end behavior here, if this arch didn't stop at the ground, it could potentially go on indefinitely, but it doesn't. This function is only defined, and this is something that I'll write down, it's only defined for the domain of 0 is less than or equal to x, which is less than or equal to 630. So that's the domain, and that just quantifies our end behavior. So that's all I have. Once you are finished with this, go ahead and submit your Unit 3 project, and I will look forward to grading those. Thank you again for joining me.